Standard 7.2, recognize and evaluate arithmetic series, geometric series, infinite geometric series, including those expressed in sigma notation. Alright, so standard 7.1 is on sequences, or finding particular terms, and then 7.2 is on adding those terms up. That's what a series is. A series is when we're finding a sum. So this whole standard is about finding sums. And I've divided our standard 7.2 into two parts. The first part is arithmetic sums, and the second part are geometric sums. So this first video is on arithmetic sums or arithmetic series, and you can find a second video on my website for geometric series. Let's look through our examples. So our first example says find the sum of the first 50 terms of that particular sequence. Now let's just confirm that it's arithmetic. So to determine whether or not it's arithmetic, you're going to find your common difference by taking any term and subtracting the term in front of it. And notice that regardless of which number you start with and subtracting the number in front of it, we always get the same value, a common value, a common difference, so to speak, right? You're subtracting. We always get negative 3. That means that it's arithmetic and that your common difference D is negative 3. Suppose that you thought it was geometric. You could determine for sure whether it was geometric by taking any number and dividing by the number in front of it. We call that our common ratio, R. So if you took the ratio of a term to its previous term, for example 3 to 6, we get 1/2, but if we do 6 to 9, we get 2/3. And so since they're not equal, it's not geometric. They're not common, right? So it's arithmetic, and we know that our common difference is D. Alright, so since it's arithmetic, we're going to use the formula for sum of an arithmetic sequence or series, and it's n over 2 times t1 plus tn. And we're finding the first 50 terms, which means the number of terms, or quantifier n, is 50. So we're finding s of sub 50. So 50 over 2. And t1 is our first term, that's 12. And tn is our 50th term. And right now our 50th term is unknown. So what we're going to have to do is find our 50th term first, and then go back and plug it in. So on the side here, let's find our 50th term. To find any term in an arithmetic sequence, we're going to use our term formula, and we're finding our 50th term. T1 is 12, N is 50 minus 1, and D is negative 3. So that is 12 plus 49 times negative 3, and you can use your calculator. And our 50th term is negative 135. So now that we've found that 50th term, we can take it and plug it back in here for t sub 50. So we have 50 over 2 times 12 plus a negative 135, or minus 135. And now if we work through our formula, we get our sum to be, let's write it up here, 50 equals negative 3,075. So that's the sum of the first 50 terms. Again, notice that in order to use the formula, you had to find your 50th term first. So you're kind of going back to standard point 1 in order to execute standard point 7.2. Alright, our second example says find the sum of the first 14 terms of an arithmetic sequence. And we're given our 5th term and our 9th term. So we have our first term, which is unknown, 3, 4, 5, our 5th term, which is 7, 6, 7, 8, and our 9th term, which is 6. And then we have some more terms all the way up to our 14th term. We want to add all these terms up through our 14th term. And we know that it's arithmetic. That's given to us. So we're going to use our formula for the sum of an arithmetic sequence, and that's S of n equals but our unknowns are our first term and our 14th term. So we're going to have to find them both. And in order to do that, what we're first going to have to do is find our common difference, D. So let's find D first. We're going to pick a term, so let's say 7, because we don't have a lot to work with, and ask ourselves, how many D's are we adding to get to our next known term, 6? 1, 2, 3, 4, right? The difference between 5 and 9 is 4. So we're adding D 4 times. 1, 2, 3, 4 to get to 6. And we can solve this equation. 7 plus 4D equals 6. 4D equals -1, or D equals -1/4, or -0.25. Which means basically we're subtracting 0.25 as we move towards the right. Now we want to find our first term, so we can plug that into our formula for T1. So let's find T1. So in order to find T1, you can do it a couple of ways. We know that it is subtracting 0.25 going to the right. So you can add to go to the left, and you have to add 1, 2, 3, 4 0.25s to go to the left. So basically you're adding 1, and you can get T1 equals 8. I mean, think about it. It makes sense because this is another span of 4, and you've gone down by 1, and then in another 4 you've gone down by 1. So you're going down by the same amount, but this time every 4 spaces. Now, if the logic is a little confusing to you, then we can actually resort to our formulas. So let's go back and find our formula for a term, and let's plug in. Now we want to find T1, so we're going to pick a Tn and the n that corresponds to it. So you could pick 7 for Tn, and then 5 would be your n value, or you could pick 6 for Tn and 9 would be your n value. Either would be appropriate. Let's pick 7. So I put 7 for Tn. T's are always terms, so 7 is our term here. T1 is unknown. N is the term number that 7 is. So 7 is our 5th term, n is 5. And I put D there, but we know D, right? It's -0.25. So we have T1 plus 4 times -0.25. So 7 equals T1 minus 1, and we get T1 equals 8. So now we know T1. And then we can plug that into our formula here. I wish I had a little bit more room, but we'll do this. So let's go back to our formula. We have 14 over 2. Now we know T1 is 8. The next thing we have to do is find T14, our 14th term. Now you can subtract 0.25 so you get to your 14th term. It's not too bad. It's not too far off. Or you could use your formula for a term again. And we're finding T14. We know T1 is 8, N is 14, so 14 minus 1, and D is -0.25. And sorry that it's hard to read, but let's continue down here. So it's 8 plus 13 times -0.25, and we can work that out on our calculator. So 8 plus 13 times -0.25, and we get 4.75. So T14 is 4.75. And now that we have that value, we can plug it into our formula here. Let me color code 8. We did was T1. We found that in green. So you can see 8 here is green. There's the work in green that goes to find it. 4.75 is in gray, so you could look at the gray work to find that. But either way, we wanted to find the sum. We had to find all these missing pieces in our formula first before we could find that sum. Now it's a matter of evaluating. So 8 plus 4.75 times 14 halves, or times 7, 89.25. So our final answer is 89.25. That's the sum of the first example says, let's evaluate, and then we have the sigma notation here. Now, sigma means to add up, so we're going to be adding up a bunch of terms. And how do we find out the terms that we're adding? We're going to take this number 3, that's our starting value for n. We're going to plug it in. We're going to continue to plug in increasing values for n until we get to 12. So we have negative 2 times 3 plus 1, so that's negative 5. That's our first term. And then we can plug in the next number up from 3, which is 4. So negative 2 times 4 plus 1, and that is negative 8 plus 1, so negative 7. And then we can plug in our next value for n. So we had n equals 3, n equals 4. Now we're going to plug in 5. And, whoops, the parentheses go there. And that's negative 10 plus 1, or negative 9. Notice that it's arithmetic. Notice that our common difference is negative 2. It's going down by 2. And that's evident that it's both arithmetic and what the common difference is by looking at our formula. It's in the form y equals mx plus b. Because it's linear, it means that it's arithmetic. And your m, which is negative 2, corresponds to the value of d. That's always true here. All right, so we continue to plug in, and then finally the last number that we plug in is the one up here, 12. So it's plus negative 2 times 12 plus 1, which works out to be negative 23. So we're adding those numbers up. Since we're adding them up and it is arithmetic, we're going to use S sub n equals n over 2 times t1 plus tn. And we know, or we have to figure out, how many terms are we adding up? Well, we started by plugging in the number 3, and then we went up to 12. So there's a space of 9 between them. But you also have to count the 3 that you plugged in. So if you count the numbers you plug in, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, it's actually 10 numbers. And the way you can find that is do the upper limit minus the lower limit, and then add 1. And you're adding 1 back in because you have to count the number that you're starting with, that you're plugging in. So it's 10. All right, so we're going to put 10 in for n. Our first term is negative 5. Our 10th term is negative 23. And then we add them up, and we find our sum. And our sum here is negative 140. Now finally, we want to condense into sigma notation. So we want to take this expression and write it in sigma notation. So there's 3 pieces that we have to determine. We have to determine what's the starting value for n, what's the ending value for n, and what formula are we plugging into. All right, so our formula is, we can always start with an n value of 1. And we want to figure out what formula we're plugging into. So notice that we are going up by 11 each time. So it's arithmetic, and it's arithmetic with your common difference as 11. So the formula for any term of an arithmetic sequence is t1 plus n minus 1 times d. t1 is negative 4, and we're going to leave as generic. d is 11, and if we distribute to simplify 11n minus 11, we get 11n minus 15. So we're going to use that for our formula, 11n minus 15. And check, if you plug 1 in, do you get your first term? Yeah. So now the question is, what's the number up here in green? How many terms do we have? Well, what term number is 128? Let's use our formula. Tn equals t1 plus n minus 1 times d. My video is going to run out in 8 seconds, so I might not get through this, but we're going to plug in what we know.